In this video, we'll solve systems by graphing, but the equations are not going to be in slope-intercept form, and in order to graph, we can graph in a few different ways. The focus for this lesson will be the transformation to slope-intercept form, where y equals mx plus b. The solution of the system is the value of x and y that make a true statement by being replaced in both equations. When we check your solution, always make sure you check it in both equations. On the graph, the solution is the point of intersection. So to graph the system, we will transform each equation to slope-intercept form. For example, 3x plus 2y equals -6 is my first equation in the system, and I need to transform it to slope-intercept form. So I want y alone, then slope times x, and the y-intercept on the other side. Using inverse operation, we'll subtract the 3x first, bring down the positive 2y, group the terms -6 and -3x. They're not like terms, so they cannot be combined. Dividing by 2, positive. We'll have the y alone, which gives us the -3/2x, which is -3/2 slope, and -3 the y-intercept. So we simplify the fraction if we can. If you can't, we'll leave it alone. And simplify the y-intercept. -6 divided by 2 is -3. That means that the line has to go through -3 on the y-axis with a -3/2 slope. So the negative direction of the line, 3 vertical, 2 horizontal. 3 vertical, 2 horizontal. Or 3 rise, 2 run. 3/2 increments. Trace the line and then transform the second equation. Second equation has -3x plus 2y equals 6, standard form. To transform, we use inverse operations. Get rid of the 3x, that would be 2y equals 3x and +6 are two terms that are not alike. They cannot be combined. Divide by 2 and simplify your divisions, fractions or divisions. 3/2, x will be the slope. The slope will be upward line going 3 up to over, or 3 rise to run, and +3, which is the y-intercept. So the +3 or +3, 0, 3 is the y-intercept. That's where the line has to go through. How does the line go? Positive with 3/2 slope. So 1, 2, 3/2. 1, 2, 3/2. You can extend the opposite direction to look for that intersection point of the two lines. And that is called solution, or a common point, or the intersection point of the two lines. So we have -2 for x, 0 for y. -2, 0 has to be our solution, but we need to check it. The values of x and y have to make a true statement by being replaced in both equations. When you check the solution, I suggest you check it in the original system, not in the transformed equations, back in the original system. So when I check my solution -2, 0, I replace instead of x, -2, and instead of y, 0. So we can see if it makes true statement. 3 multiplied by -2 plus 2 multiplied by 0 should be -6 in the first equation. Multiplications first, based on the order of operations, -6 plus 0, and then -6 plus 0 is -6, which makes a true statement. And you always have to check the solution in both equations. So in the second equation, -3 times the x value, -2, plus 2 times the y value, 0, should equal 6. Well, negative times negative is positive, so multiplication first. Plus 0, and 6 plus 0 equals 6, which works in both equations. So the solution, negative 2, 0, is a true solution because by being replaced in both equations has given us true statements. In the next example, we have two equations and we need to see what the solution is. To graph, I will use the transformation method to slope-intercept form. So x minus y equals 3 is the same as 1x minus 1y equals 3. Subtract the 1x from both sides. Bring down the negative 1y. So keep in mind the sign needs to come down with the term because if we miss the sign will affect the direction of the line. So negative 1x plus 3, because negative 1x is the term with negative and 3 is positive, so negative 1x plus 3. Dividing by negative 1, both sides, each term needs to be divided by negative 1. Negative divided by negative is positive when we simplify, and then positive divided by negative is negative. So this line has positive slope, 1 by 1, and negative y-intercept. So the negative 3 on the y-axis, and then we go upward 1 by 1 for positive slope. Second line has the original equation, 2x minus 2y equals negative 8. Using inverse operations, subtract 2x on both sides, that will be 0. Negative 2y will come down. Divide by negative 2 and simplify. Negative divided by negative again will be positive. 2 divided by 2 is 1. That would be the slope. And then negative divided by negative is positive 4. That will be the y-intercept. So that means that our line has to go through 4 on the y-axis. That's the y-intercept. How does the line go? With slope 1 by 1 positive, which is the same exact slope from the previous line. If the slopes are the same, it means that the lines will be parallel. Parallel lines never intersect. On the graph, the solution is the point of intersection. Parallel lines never intersect, so this system has no solutions. Why? Because the lines don't cross, they are parallel lines. Parallel lines never intersect. Next example, we'll see the third type of an answer. But before we see it, we need to graph these two equations and we transform them to slope-intercept form. So first equation, 2x plus y equals 4. By subtracting the 2x, the y is alone right away. So negative 2x plus 4 is showing negative direction of the line, 2 by 1, through 4 on the y-axis. 1, 2, 3, 4. We start with the y-intercept. And then negative 2, or 2 by 1, because in the fraction, negative 2 will be the rise and 1 run. Negative 2 over 1. Downward we go 2 by 1, 2 by 1, 2 vertical, 1 horizontal. 2 up, 1 over. Negative direction of the line. Now careful on the second equation. We have negative 6x equals 3y minus 12. This is 6x over negative 6x, the x term that needs to come over this way. And this is 3y, which is the y term that needs to come over this way. My goal is to create slope and intercept. So y equals mx plus b. This is the goal that I have, this is the equation that I have. The only term in the proper place right now is the constant. The x term and the y term need to be switched up. So that means that I have to use the inverse operation. You can start by adding 6x to both sides, or you can start with subtracting the 3y to bring it where it belongs. So negative 3y, I'm going to take it from the right side and then do the same on the other side to bring it over where it belongs. Negative 3y minus 6x equals negative 12. Then, using inverse operation, you add the 6x to get rid of it from here and move it over to where it belongs. Negative 3y will come down, and then positive 6x minus 12. The terms that are in slope location and constant y-intercept location. So dividing by negative 3 will give us the y alone, and then we simplify the fractions. Positive divided by negative is negative 2, or 2 over 1x. Negative divided by negative is positive 4. So this equation now is exactly the same as the original or first equation. That means that the line will go through 4, the same direction, negative 2 over 1. So when we graph it, it overlaps with the first one. So the first line and the second line are overlapping. So they share all the points. Every single point of one line is in common with every single point of the other line. This is when we say that this system has infinitely many solutions. Infinitely many solutions. Overlapping line, first and second, share all the points. All the points of first line are in common with all the points of the second.